My name is Bill Sanders. I am the fossil preparator in the University of Michigan's Museum of Paleontology in the Vertebrate Fossil Prep Lab. And I'm going to talk to you today a bit about a really interesting animal that is on display in two cast skeletal forms in the University of Michigan Museum of Natural History. An animal called Maiacetus inuus, the mother of whales. Maiacetus means the mother of whales. These whales are archaic fossil whales from about 48 million years ago, found in eastern Baluchistan in what is now Pakistan by a joint expedition from the University of Michigan and the Geological Survey of Pakistan. These skeletons were found in 2002 and 2004. Although I was not involved in the field work at that time to recover these skeletons, I have worked in the area. I'm very familiar with what is involved to remove fossil skeletons out of the ground in eastern Baluchistan and how hard it is to get them out. My job is primarily to prepare the fossils, that is, to get them out of the rock safely, to reconstruct their missing parts, to stabilize them so they don't fall apart and can be studied in the future, and to make molds and casts of them. Now, the area that these fossils were found in, these Maiacetus fossils were found in, is today raised very far above sea level and is in a very desertic area. But in the past, when these animals were alive, Pakistan was not part of a land mass and was not in a mountainous area. It was part of an archipelago, and the rocks where Maiacetus is found are near-shore marine rocks. Now, how did they get so far above sea level? How did these whales get into these mountainous areas? And the answer is that at the time that these whales were alive, 48 million years ago, Indo-Pakistan was an archipelago, stretched out into the Tethys Sea, or what is now the Indian Ocean. And because of movements of the plates of Earth, Indo-Pakistan has slowly moved into the underside of Asia, collided with Asia in a very violent collision over a long period of time. And the rocks that Maiacetus are in are lighter than those of Asia, and so they have gone up and the rocks of Asia have gone down. One result of this is the Himalayan mountains, which has been thrust up, pushed up by this action. What made these fossils extraordinary and what makes them interesting to be on display in our museum for you to learn about is that the male specimen, there's two specimens, a male and a female, adult male and adult female. The adult male is nearly complete, virtually complete, and it is the only virtually complete fossil archaic whale, protoceded whale that we have. When you have a complete skeleton like that, it can tell you a lot about how whales moved in those days, how they swam, what they might have eaten, how big they were, what their sex and age was, all sorts of things that you can learn when you have a complete skeleton. We know from this male that he has very large hind feet and probably was propelled by the swimming action of these feet. He had smaller hands and compressed forelimb bones, probably used to steer in the water. There's no sign of a modern type fluke on this whale, but the tail is heavy, so the tail was probably used the way that a muskrat might use its tail for balance in the water. This male is extraordinary. It's a Rosetta Stone for helping us to identify isolated bones of other archaic protoceded whales from this time period, this early Eocene time period of 48 million years. The female skeleton is even more extraordinary. Although she is less complete, missing many of her bones, she has most of her skull and part of the skeleton, but part of the postcranial part of the skeleton. But what's extraordinary inside of her is that she has a fetus inside of her, and that's almost never something that you would expect to find in the fossil record. When I started preparing this particular fossil under the microscope, under fine magnification, I started seeing things that looked like little raisins and things that looked like little toothpicks. And I didn't know quite what to make of these things. As I carefully prepared them using little pins and a tool called an air scribe, it became apparent that I was looking at a little tiny skull, and the little raisins were teeth, and the little toothpicks were ribs, and that there were in fact some very small vertebrae and some very small long bones. This is an extraordinary find. And one reason it's extraordinary is the orientation of the fetus inside of the mother tells us that this baby would have been born head first like a terrestrial mammal and not like a fully aquatic mammal, like a whale, for example, like a modern whale. Now that's interesting. These whales still had the ability to come out on land, and so this is some confirmation that we're looking at a semi-aquatic amphibious whale, not a fully aquatic whale. So they're like seals and sea lions having their babies on land. That was an extraordinary find. We took this skeleton to Germany, where it was photographed under special ultraviolet means, and that brought out the infant bones relative to the mother's bones in really stark contrast. It was very easy for us to see what was infant and how the infant was inside of the mother, how it was articulated inside of the mother. So that was an extraordinary find. We have a complete male, a complete female, 48 million years old, at the cusp of whales becoming aquatic. Now, we have other bones in the male that tell us a lot more about relationships, for example. So the male has an astragalus, an ankle bone, that we say is double pulleyed in its anatomy. The only modern animals, the only animals we know with double pulleyed astragali are artiodactyls, things like cows and giraffes and pigs. Well, a whale, it turns out, is a very bizarre, odd-looking artiodactyl. And in fact, geneticists doing comparative study of DNA have determined that whales and hippos are the most closely related living animals. So this was paleontological confirmation of a genetic idea. And in science, we like to say that those are very powerful ideas when they're supported by multiple lines of evidence. So today we know whales are really bizarre artiodactyls. We know that early whales could come out of the water, had to come out of the water to have their babies. Their babies were small, like the infant inside of the Maiacetus mom. We call the Maiacetus mom the mother and child reunion whale. Now, if you come and you visit the University of Michigan Museum of Natural History, you can see casts of the mom and the fetus on display and casts of the male complete and repositioned, reassembled the way it would have looked in life, at least the way the skeleton would have looked when he was alive. And this is an extraordinary thing. To this day, there is not another as complete protocoetid archaic whale as the one we have on display. So it remains the most extraordinary early whale specimen on display for the public to see.